I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
In this video, we're going to look at domain and range of relations or functions. Remember, domain is the x values and range are the y values. You need to make sure you know those words and know that they're interchangeable. So in our first example, we have a table of values. And so our domain, again, is the x. Our domain is -3, 4, 6, and 2. Now, I will tell you that it is more correct to actually list these in order from least to greatest and not necessarily in the order that the table gives it to you. So I would actually list this as -3, 2, 4, and 6. My range in order from least to greatest, well, it's actually already in order, is 5, 6, 7, and 8. So that is my domain and my range. Here we have a mapping diagram. Again, I mentioned a table really helps me to see this better. So I'm going to go ahead and make a table. So 3 maps to 0, 2 maps to -4, and 5 maps to 1. Notice that the -2 has nothing mapped to it, so it's actually not a part of my range. So domain is going to be 2, 3, 5, and my range will be -4, 0, and 1. If you have an x value or a y value that is repeated, you would not repeat it in this list. You would only list the number once. So the value is either a part of the domain or it's not. So remember we said the x can't repeat, but the y can. So if the y repeats, that's fine, but you don't need to list it more than once. Now let's look at a graphing example. Now, this is what we call a discrete graph. All I see here are 5 points. I don't see any lines connecting those points. So that is a discrete graph. So I'm going to go ahead again, do my favorite thing, make a table. So here are those ordered pairs listed in a table. So now I can very easily list my domain and my range. So my domain in order from least to greatest, well, the way I looked at my graph, I actually went from left to right. So again, mine are actually in order. So -6, -3, -2, 1, and 3. And my range is going to be 3, 4, and 6. So here's an example where the 4s and the 4 and the 3 repeated, but again, I would only list them once. So I have 1, 2, 3, 4. I have 5 values for my domain, but only 3 for my range, but that is okay. This is an example of a continuous graph, which this is a function. It does pass the vertical line test. When we have a continuous graph, our domain and range are going to look a little bit different. We are going to use inequalities. We're not just going to make a list like we did before. So when I'm looking at this graph, this function, I want to think about what are all the possible x values. So if I look at my graph, how far left does it go? Well, it does not go past that point. And how far right does it go? Well, the furthest right it goes is over here. So that means that my domain is from -6 to 5. Now remember, domain is x, so I'm going to use the x variable. And what this means is my x value can be anywhere between those two. So I'm going to use the less than symbols. Why? Because x is greater than -6 or x is less than 5. Well, can x equal -6? Yes, because of this closed circle here, it can equal -6, and also a closed circle here, it can equal -5. So this is how you would express the domain. You would use an inequality because it's a continuous function. Now let's look at the range. When we're looking at the range, we want to look from bottom to top. So what's the lowest this graph goes? So the lowest it goes is right here, and the highest it goes is right here. So the range goes from -5 to 3. And remember, those are the y values. We're still going to use a less than symbol. Can it equal -5? Yes, it can. Can it equal 3? Yes, it can equal 3. So negative 5 is less than or equal to y is less than or equal to 3. It really helps if you use highlighters, kind of like I did here, to be able to see the domain and the range. Again, domain is from left to right and range is from bottom to top. You have to make sure that these numbers are in order from least to greatest. It would not make sense if the 5 was on the left and the negative 6 was on the right. Let's look at one more example. This again is a discrete graph because there are holes in the graph. However, there are parts that are continuous. So there are parts of it that are continuous, but as a whole, it's a discrete graph. So let's look at the domain. Well, the domain goes from here to here without a break. If you look at this section right here, okay, it stops here, but then it picks up down here and starts again. So the domain for that is going to be negative 5 is less than or equal to x is less than 3. So take a look at that graph, specifically the part that I just highlighted, and see if you can figure out where I got this domain from. If you can't, you need to make a note of that and ask me. Now, we've left off this section and we can't do that. So we need to consider that. So this goes from here to here. Now, if you notice, this is an open circle there. So that part of our domain is 4 is less than x is less than 7. Now, are either of those equal to? The 4 is not equal to because that's an open circle, but the 7 is equal to because it's a closed circle. So this right here is our domain. There's two parts to this. It's both of these. Now let's look at our range. So it goes from down here to up here. And again, you have to pay attention to, are there any holes? Well, this is continuous to here, and this is continuous to here. And so actually, at some point, all of the values in between my green highlighter are covered. So my range is going to be from -1 to 4. I'm going to use my less than symbols. Now let's look at the -1. Are those closed circles? Yes, they are. So that's equal to. And the 4 at the top is not a closed circle, so that would not be equal to. So this is our range.
I've been waiting way too long.